Everybody. Good morning, Manitoba. Are you awake? Good. Just like in her joke, she did the same thing with me. She asked me once whether I want to present, then she asked me twice, she asked me 3 times, and I said yes. So I have been invited to talk to you about a pretty contentious issue, the impact livestock has on climate. And I know that everybody here has been hearing about it day in, day out. Yesterday, I went to my hotel room and I did something I normally don't do very much anymore, and that was watching TV. And there was some advertisement, one of them by a margarine company, where the wife asked her husband, why do you put butter in our food? I thought we are no longer doing cows. And he said, no, we're not doing cows. This is not from cows. This is plant-based. And so I thought, geez, it's here too in Manitoba. And so it's everywhere, and no matter where you go in the world, the news anywhere in the world is full about livestock's impact on climate. It is, in my opinion, one of the Achilles heels of animal agriculture. If you really want to hit animal agriculture hard, talk about its climate impact. So that's what I've been observing for many years. I've been in this business of assessing the impact livestock has on air in general. I'm an air quality specialist, and that includes also climate pollutants. And so I've been in it for the last 22 years at UC Davis. Pam mentioned that I'm the leader or the director of the CLEAR Center. This is an effort in not just doing research on and around sustainability topics, but also communicating those. A few years back, I started being asked, Frank, you give many talks throughout the year to audiences like this, and these audiences are largely within agriculture, and so that's great that you do this, but what about the rest? What about talking to high school students? What about talking to college students? What about talking to policymakers and agency folks and the public at large? And I received support by my university, the University of California, to establish a center that does that, research and communications. So I hired journalists, filmmakers, social media experts, in order to tell the story of agriculture. Not marketing, not PR, fact-based communication around what we do, how we do it, why we do it, and wherever we need to make changes, also promote changes. So, the whole contentiousness of this issue of livestock and climate, I would pin to one event, and that was back in 2006, a report by the United Nations Food and Agriculture Organization, FAO. This report is called Livestock's Long Shadow, or was called Livestock's Long Shadow, and what it said was that livestock and poultry produce 18% of all greenhouse gases, leading to climate change. Those of you who are higher in the tooth, you might remember that report. It was talked about a lot. It also said that livestock and poultry produce more greenhouse gases than the entire global transportation system. That means that cows and pigs and sheep and chicken produce more greenhouse gases, leading to a changing climate, than all cars, trucks, trains, planes, ships in the world combined. Does that sound credible to you? Anybody here? Okay. And it said that 70% of all agricultural land is used for livestock and poultry. And all these topics had been discussed over the following years, day in, day out. When I got my hands onto this report, I asked my graduate students, I always have 6 PhD students in my lab, I asked them, does this sound credible to you? And everybody shook their heads just like you do now. But as a scientist, shaking our heads is not enough, obviously. We have to find evidence to prove or disprove the validity of something like this. And very quickly we found that there were some very systematic problems with this report. One of the main problems was, so first of all, I critiqued the number 18%. I didn't believe the 18%. But more importantly, I really critiqued the comparison of livestock to transportation. And I found very quickly that for livestock, the United Nations FAO looked for the impact livestock has on climate using a LCA approach, life cycle assessment approach, where you look at under every stone, you look at not just how much the animal emits, belches out, or her manure, or his manure, but you also look at the entire life cycle from grazing, soils, plants, the animals, the transportation of products from the farm or ranch to a market, the processing of these products, all the way to the consumer eating it. That's a life cycle assessment. So the FAO did that for livestock. But they didn't do the same thing for transportation. For transportation, they only looked at tailpipe emissions, meaning what happens when you burn gas to get from A to B. What comes out of the tailpipe? They didn't look into the production of cars, trucks, trains, planes, ships, all the steel, rubber, plastic going into that, all the inputs into building roads and highways and airports and so forth. None of that was considered, but only tailpipe emissions. But then they compared the life cycle emissions of livestock to only direct emissions of transportation. I went out on an American Chemistry Society event in San Francisco, and I shared with my audience the beef I had with the report. And after I finished my presentation, I noticed that one person in my audience was not a scientist, but an Associated Press journalist. And he came to me and said, Dr. Mitterlehner, are you aware that you're just messing with the world's most powerful agency in and around food and agriculture? I said, I'm not messing with it. I'm just saying I don't believe the premise of the report, and here's why. So I gave this person an interview. And then right after I gave him an interview, he called the FAO in Rome and asked them for a statement. And so here is what came out of it. So first of all, Livestock's Long Shadow, this is what it is. The first one who picked up on the Associated Press story was the BBC in London, titling their story, UN Body to Look at Meat and Climate Link. UN specialists are to look again at the contribution of meat production to climate change after claims that an earlier report, which is Livestock's Long Shadow, exaggerated the link. So again, they interviewed me, and then they interviewed one of the authors of Livestock's Long Shadow, who said, I must say honestly that he, Mitterlehner, has a point. We factored in everything for meat emissions, and we didn't do the same thing for transportation. Now, I give them a lot of credit for having taken responsibility for that. The problem is, the horse had left the barn, and everybody who had reported up until this point about the impact livestock has on climate now didn't want to correct their earlier assessments. And that put me square in the center of this debate, because now I was the guy who rebutted Livestock's Long Shadow. So everybody who has a beef with livestock had a beef with me. And that's not exaggerated. That's really the truth, okay? So I will now break this whole topic down. And some of it is quite technical, and I'm avoiding the technicalities, but if anything is unclear, stop me at any given time. First of all, what is all this talk about greenhouse gases and climate change? What are greenhouse gases? Greenhouse gases are molecules like CO2, methane, nitrous oxide. Before I go into this, just let me give you an analogy, okay? I see some of you have a cup of coffee in front of you. Let's say that we're a styrofoam cup. You can put your coffee in there, or you can put it into a China cup, or you can put it into a Starbucks $20 insulated cup. The same coffee going into those 3 beverage containers stays warm different length of time, depending upon which beverage container you pick, right? The same is true with these greenhouse gases, CO2 versus methane versus nitrous oxide. When they're hit by a solar beam, they actually heat up. And they trap the heat from the sun, just like your beverage container traps the heat from your coffee. But at different potency, they're not the same. Methane is more heat trapping than CO2. Nitrous oxide is more heat trapping than the others, okay? And I will get to that in just a minute. So greenhouse gases in general trap heat from the sun, and they form pretty much a blanket over our Earth's atmosphere. So imagine solar radiation coming in. Normally it would be reflected back into space, but now there's this blanket of greenhouse gases that is retaining some of that heat in our atmosphere. In fact, without these greenhouse gases, life on Earth would not be possible. It would be too cold. So what's the problem with greenhouse gases? The problem is humanity is producing too many of them, and that makes that blanket too thick, and that means we are retaining more and more heat from the sun. That's why it's a problem, okay? We need some greenhouse gases, but we don't want to have too many of these molecules in our atmosphere. So that blanket is the reason why we are discussing global warming. If you look at all the different sectors of society contributing to greenhouse gases, you find a lot of red here. And red means the burning of fossil fuels, that's oil, coal, and gas, to run our vehicles, to heat our homes, to run industries, and so on. So the burning of fossil fuel is the #1 source of greenhouse gases, and here chiefly CO2 as the main greenhouse gas. But you see globally, and this is a global slide, globally, agriculture and forestry also have a significant contribution, particularly, by the way, agriculture in developing countries of the third world. The Intergovernmental Panel for Climate Change, IPCC, estimates that 80%, 80, of livestock's greenhouse gases globally, 80% of livestock's greenhouse gases globally stem from developing countries, and 20% from developed countries. This is not a finger-pointing exercise to deflect off responsibility from what we do, but it is just noting the fact that the majority of the topic really develops in developing countries. I mentioned it to a colleague yesterday, the two countries of India and Brazil. These two countries have more cattle than the rest of the world combined. So there are some hotspots, okay? And in addition to India, Brazil, there are countries like China. There are a handful, really, where the vast majority of greenhouse gases from the livestock sector are associated with. If you look at the US, so the previous slide was global in the US. This is the cake of greenhouse gases. You can see transportation, roughly a third, power production, roughly, and use, roughly a third. You see here what the cake looks like. Agriculture in the US is responsible for almost 10%, and according to the EPA, the Environmental Protection Agency, all of animal agriculture combined is responsible for roughly 4% of all US greenhouse gas emissions, 4%. That number is very similar around most developed countries. So most countries in the European Union and so on have an emission profile like that. There are a few exceptions like Ireland or New Zealand or so, where the livestock sector is super important and where those emissions are higher. But in most developed countries, it looks like this. So we are not nothing, we are something, but we are definitely not the 800-pound gorilla. And as you know, many people like to make us look that way. This is a slide that makes my blood boil. And you find it everywhere, all over the media. This slide is used. And what does it show? It shows different food items, and I know the font is small, and I'll walk you through this. And on the x-axis, it says greenhouse gas emissions per kilogram of food product. What the makers of this slide did was they compared a kilogram of beef to a kilogram of lamb, cheese, chocolate, coffee. I go down the list here. Tomatoes, bananas, and their carbon footprint. As if a kilogram of tomatoes were even close to be what a kilogram of beef is in the nutrition of humans. They did not use a denominator that would have made these food items even close to be similar, but they used completely different products and then said, yeah, you see here clearly beef is a problem because look at the carbon footprint per kilogram of product. That's ridiculous. That's like comparing an airplane to a bicycle to a car. They're all vehicles, yes, granted. But how ridiculous would that comparison be? And when you look at the different food items, then the main greenhouse gas associated with ruminant products, such as beef or lamb, is methane. Methane is what it's all about, and methane is what I'm about to talk to you about. Why is methane so important? Methane is so important because it has a high potency in trapping heat from the sun. I just told you these greenhouse gases, CO2, methane, nitrous oxide, are not created equal, just like the beverage containers. One molecule of methane traps the heat almost 30 times better than one molecule of CO2, and nitrous oxide even more so. So these are different. To my students at UC Davis, I always say, because sometimes they have a hard time visualizing that, just imagine the three of us were to go out and drink. One of us drinks a glass of beer, one of us drinks a similar volume glass of wine, and one of us drinks a similar glass of vodka. Who would be drunk first? They all get that, okay? There are different potencies in greenhouse gases. That's the bottom line here, okay? But the way of comparing those, the so-called global warming potential 100, this is the matrix that has been used for the last 30 years. That matrix is significantly flawed. And I was one of the first scientists to criticize it. And the reason why that's a problem is because it has been used for the last 30 years. And when you use it, for example, for livestock looks really bad. So why is there a problem with GWP 100? With this way of simply saying methane is 28 times more potent than CO2. The reason why this matrix is a problem is because it leaves out a very important nuance, which is depicted on this slide. This slide shows the global methane budget. It shows on the one side here various sources of methane, including fossil fuel production and use, agriculture and waste, biomass burning, and so on. All of these sources, ladies and gentlemen, amount to a total of 500, I call it 560 teragrams of that gas globally, 560. What the media that reports on methane leaves out, routinely leaves out, maybe even intentionally leaves out, is the fact that methane is not just produced by sources, but there are also significant sinks in the world. And if you look at the number, 550 teragrams of methane are destroyed naturally. 560 are produced, 550 are destroyed. Do you think that matters when you account for a gas like methane, to acknowledge that it's not just produced but also destroyed? Does it matter? Of course it matters. It's like you going to your bank saying to your banker, from now on, we only account for my income and not for my expenses. That's what they are doing. What is it that is a significant sink for methane? It's depicted here, a large arrow pointing down. It says underneath, sink from chemical reactions in the atmosphere. What that means is that if this were a methane molecule, within approximately 1 decade, that methane molecule meets another molecule called a hydroxyl radical. And this hydroxyl radical destroys the methane. It takes about a decade. And it's long known, we've known this for a long time. It's called hydroxyl oxidation. That's the name of the process, okay? And it accounts for a whopping 550 teragrams of methane being destroyed. And this is why, ladies and gentlemen, methane is so different from other greenhouse gases. Because CO2 and nitrous oxide are produced by various sources, but not destroyed by anything else in the atmosphere. Methane is. And because of that, it's not good enough to simply say methane is 28 times more potent than CO2, and that's the end of the story. It is true it's a potent greenhouse gas, but it's also true that it has a very short lifespan. And why that's important, I will show you in the next couple of slides. So if you want to know what the net is globally, you need to subtract the sinks from the sources, and out come the net. And I want to be very clear about that. Frank Mitloehner is not saying to you methane doesn't matter because it's not just produced but also destroyed. Because we still have a sizable chunk that we need to further reduce. And yes, our industry is producing methane. So we are part of that picture. But we are not the main part of the global climate issue as often depicted. What I just said accumulates in this slide here, namely the fact that the different gases have a different lifespan. Once you drive a car, the CO2 that comes out of the tailpipe of your car stays in the air for roughly 1,000 years. What that means is that every time you've ever burned oil, coal, and gas through any activity in your life, that CO2 that you've put out is still in the air in 1,000 years. The same is not true for your cows. If they belch out methane today or produce, let's say, methane through their manure, then that methane will stay in the atmosphere for roughly a decade, and then it will be gone. While it is in the atmosphere, it traps heat. It's a very potent greenhouse gas during those 10 years. But after 10 years, it's gone. CO2 not. And as you can see, nitrous oxide is not just a potent greenhouse gas, but it stays in the air for a long time, for well over 100 years. So CO2 and nitrous oxide are long-lived climate pollutants, and methane is a short-lived climate pollutant. That's one important learning of this talk here in the morning. To show you the difference between CO2 and methane, I use a couple of slides here. So imagine you were to live 20 miles away from work, and every day you drive to work. On Monday, you do that, you burn gas, you put CO2 in the atmosphere. On Tuesday, you drive the same distance, and you put new additional CO2 into the atmosphere. On Wednesday, you do it. On Thursday. Every time you burn fossil fuels, you add new and additional CO2 to the existing stock from the previous day, the previous week, the previous month, the previous decade, and so forth. You get the gist of it. Every time we burn this we burn fossil fuels, we add additional CO2 that we add to the existing stock of CO2. That's why this gas is called a stock gas. Currently, most people reporting on methane act as if the same were true for methane, as if every day our cows belch or their manure produces methane, that were to be additional to the methane from 10 years ago, 20 years ago, 30 years ago. But that, ladies and gentlemen, is not true, because methane is not a stock gas. Methane is a flow gas. It's not just produced, but it's also destroyed. And this is what it looks like. If you have a constant source of methane, let's say a constant herd of beef cattle. Let's say you have a ranch with 100 cattle, and you used to have 100 cattle 10 years ago, and 20 years ago, and 30 years ago, and 40 years ago. Then these animals, of course, produce methane, but over time, an equal amount of methane that was produced by your cows would have also been destroyed. And that would mean that the methane concentrations would be constant, and that would mean that the related warming would be constant. Okay, a constant source of methane causes a constant amount of warming, no additional warming. The Paris Climate Accord, for example, is asking that humanity is not adding additional warming to our atmosphere beyond 1.5 to 2 degrees. Everybody has heard that one way or another. No additional warming. If you have a constant source of methane, you're not adding additional warming. Okay? So methane and CO2 are not the same. I will now give you an analogy, because you just noticed that I like analogies, using the coffee cups. Imagine a bathtub analogy for first CO2 and how that warms the planet versus methane and how methane warms the planet. I will use a bathtub analogy, where you have a bathtub in the CO2 scenario that has a faucet, but it does not have a drain. When you turn that faucet on low, on normal, on high, what happens to the water levels? They go up. They can only go up because there's no drain. And this is what it looks like. Oh, no, it looks like that in a few minutes, I think. I'll get to that in a few minutes. So now I'm thinking, have I included those slides? I'm not so sure. So let me first complete that analogy. The second bathtub analogy is one where methane warms the planet. Here you have both a faucet, but you also have a drain, and the drain is always open. That's the hydroxyl oxidation. The drain is always open. So if you turn the faucet on normal, then an equal amount of water that goes into the bathtub is let go off through the drain. As a result, the water level stays stable. If you turn the faucet on low, but the drain is open, what happens to your water levels? They can actually go down, because now you're extracting more than you're replenishing. And only if you crank that faucet on full all the way, then you can have rising water levels despite the fact that you have an open drain. I think that's clear to everybody. That's the difference between CO2 and how it warms the planet, no drain, no destruction, versus how methane warms the planet, where we have a destruction of this gas. So it really matters. This slide here is a slide that can confuse the hell out of people, so please really pay close attention. It's called the biogenic carbon cycle, and it answers the question where the carbon that makes it into methane, where it comes from and where it's going. And then I will contrast that livestock scenario around carbon to where fossil fuels come from and where they are going, and that related carbon. So in the case of methane from livestock, CH4, the carbon, the C in the methane, originates in the atmosphere in the form of atmospheric CO2. The plants that our animals eat, whether it's grazed vegetation or harvested vegetation that we feed in the form of a TMR, those plants take on CO2 from the atmosphere during photosynthesis. And they take that carbon from the CO2 and they make it into carbohydrates, such as cellulose or starch. And then our animals, in this case our ruminant animals, eat that plant-based material, and in their rumen they will produce, on the one side, volatile fatty acids, but I won't go there. But they also produce methane. Some of those microbes in the rumen are methanogens, and there are some others, and they will produce methane. That's the unintended consequence of a huge asset we have in our ruminant animal population. Namely, the asset of having animals that use something that nobody else can digest, which is cellulose. They are the only ones who can digest the world's most abundant biomass, grasses, cellulose contained in grasses. Without those microbes, the cellulose could not be digested. But the unintended consequence of that digestive process is methane formation. That methane, by and large, is belched out. Some more comes off animal manure decomposing. But, ladies and gentlemen, is the carbon in this methane, is that carbon new and additional to our atmosphere? How many of you say it's new and additional to the atmosphere? Nobody. Okay, but you're all biased because you're all in agriculture. It is not new and additional because it was in the atmosphere before, but in a different form. It was in the atmosphere before in the form of CO2. So where is that carbon going now? That carbon is undergoing hydroxyl oxidation, and after roughly 1 decade, it goes back to where it came from, CO2. And now you might say, well, is that a good or bad thing? You just said that CO2 has a lifespan of 1,000 years, methane a little over 10 years, so is that a bad thing? It's neither a good or a bad thing, it's a thing. It's not adding additional carbon to the atmosphere because the carbon up here was carbon before, and the form was even the same. It was CO2, it will become CO2. This whole thing here takes 10 years, approximately. It's a short-lived carbon cycle. What I'm telling you here is not that methane from livestock doesn't matter because it's cyclical. I want to repeat that because it's so important. What I'm saying to you is not that biogenic methane doesn't matter because it's cyclical. It does matter because while it is in the form of methane, it is heat trapping. And that's why we are still focusing or putting a lot of focus on mitigating that gas. But the carbon cycle from livestock does not add additional carbon to the atmosphere unless we increase numbers of livestock. I want to contrast that to fossil fuels. Fossil fuels are things such as oil, coal, and gas. I use them the way you use them. So I'm not here pointing fingers at others. I'm just explaining where they come from and what they are and where they're going. So fossil fuels are oil, coal, and gas. They used to be plants and animal lives from hundreds of millions of years ago. They died, decayed, fossilized, and accumulated underground until 70 years ago, 70, humanity started to extract them at large rate. And since that time, since the last 70 years, we have extracted half of those fossil fuels from the ground, and what did we do with them? We burnt them with cars, trucks, trains, planes, ships, and so on. So where's that carbon that was in the ground for so long? Where's that carbon now? It's in the atmosphere. And every time we burn it, we add more of that to the atmosphere. I think it should be clear to everybody here that this is not a short-lived cycle. This is a very long-lived or long-time one-way street, which is contrasted on this slide where you have the fossil fuel being extracted and then burned. This is ancient carbon that's added to the atmosphere. Every time we do so, we add additional warming. Now comes something very important to you, I think. I want to repeat the biogenic carbon cycle of atmospheric CO2, making it into our plants during photosynthesis. Some of that carbon stays above ground, but about 90%, 90, of that carbon goes below ground, first into the roots of those plants our animals eat, and then that carbon is taken on by soil microbes, a process called soil carbon sequestration. Soil carbon sequestration takes atmospheric carbon, it puts it in the ground, and it stores it in the ground. It stays in the ground unless we plow the fields, in which case that carbon comes back out. But if we, let's say, use grazing, then we are not releasing that carbon back into the atmosphere, but we're keeping it there. How much your livestock and your grazing land contributes to soil carbon sequestration, I don't know. And we don't have enough scientific evidence to quantify it today, but we know it's a lot. Estimates out there are that about 1/3 of all human-caused carbon, meaning from fossil fuels, about 1/3 of that ends up being sequestered in soils. So soils are very important. Treating those soils well, having healthy soils is absolutely essential with respect to us in agriculture, mitigating climate impacts. We can do it in agriculture. Our colleagues in forestry can do it. No other sector of society can. So to make farmers the enemies is one of the most misguided things that society can do. We're an absolutely essential part of society in our fight against the changing climate. So our animals, of course, eat some of the above ground vegetation and therefore some of the carbon that's contained therein, and they're belching it out, and after about a decade it goes back to CO2. So I hope by now everybody sees that fossil carbon versus biogenic carbon are really different. So here you have a faucet, it's on, there's no drain. As a result, water levels go up. They can only go up, they cannot go down, no drain. That's what happens with CO2 and how that gas warms the planet. The next slide is methane, CH4. Here you have a faucet, but you have an open drain. If the faucet is on normal, water levels stay stable. If you turn the faucet on low, water levels will go down. What that means to us is, if we manage methane, if we reduce methane, we can reduce warming. If we reduce methane, we can reduce warming. And that can make animal agriculture part of a climate solution, even short term. For those people who think this is greenwashing, I have news. It's not. It's physics and chemistry. We know that when we reduce methane, we are replenishing less of that gas than is naturally destroyed. And that means levels go down. And that means warming goes down. And this is here what it looks like. I want to contrast two sources, one for CO2, one for methane, under three scenarios. The first one is the following. Imagine a power plant which over 30 years increases the amount of power that's produced. When they do so, they increase the CO2 that comes out of that power plant. CO2 levels go up. What happens to the related warming of that CO2? It goes up, and exponentially so, because this gas accumulates, and over time, an accumulating gas will lead to an exponential increase in warming. If, let's say, you have a feedlot with 10,000 cattle and you increase the numbers to 15,000 cattle over 30 years, let's say, then you're increasing the methane. And increasing methane leads to increasing warming. This would mean cranking that faucet on all the way, on high, and now you're overwhelming what goes out through the drain. Okay? Then the water levels can rise. Now comes the second scenario, where the power plant over 30 years produces an equal amount of power and therefore an equal amount of CO2. Look what happens to the related warming. It goes up. It strongly goes up because that gas accumulates. You remember that pyramid I showed you before. But look what happens when you have a feedlot with 10,000 cattle, keeping its numbers stable. After 30 years, it still has 10,000 cattle. Then that constant amount of a methane source will lead to constant amounts of warming, and that would satisfy the Paris Climate Accord. A constant source of methane does not lead to additional warming, but to constant warming. That means you put that faucet on normal, the drain is open, the water level stays stable. Now comes the third scenario, the one that gets me excited. And that is what happens when we reduce both a fossil fuel source, like the power plant in red, versus a methane source such as a feedlot. Let's say the power plant over 30 years decides to produce less power over time, and at the end, they shut it down to be net zero. And then they replace it with nuclear power or something else. Look what happens to the related warming of the decreasing CO2. Even though we are decreasing CO2, the warming still goes up, and it will continue to do so until we shut down the CO2 source. And at that time, the related warming will plateau. If we were to stop burning all fossil fuels in the world today, no more burning of oil, coal, and gas today, then that would not mean that we are going down in warming. We would plateau in warming for thousands of years. That's how important CO2 is. Now look what happens when we reduce methane. When we reduce methane, we instantaneously reduce warming. People ask me, Frank, is methane a super pollutant? And I say to them, in my opinion, CO2 is a super pollutant because even though it's less potent per molecule, it lives on pretty much forever warming our planet. Whereas to me, methane is a super opportunity because if we learn how to manage this gas, we can contribute to be a climate solution. And that's how I see it. The question now is, can we get to this scenario? Is it possible for us to reduce methane in a sizable way? I have to keep an eye on my time here. Okay, so what you see on this slide here are different regions in the world on the x-axis, and on the y-axis you see methane. On the y-axis you see methane. You see here different parts of the world have different amounts of methane. In blue here you see how much is related to livestock. So it's a sizable chunk. The main livestock species contributing to methane are ruminants and in particular cattle. And the main source is enteric, meaning that's the methane they belch. If you think about the consumption of animal source foods in the world, and whether it's going up or down or plateauing, this is what we see. In Asia, consumption of animal source foods is going up. In the Americas, it's going up. In Africa, it's going up. In Europe, it's plateauing. But by and large, livestock consumption is going up. At the same time, we are seeing this picture here. I'm in my mid-50s. When I was a little boy, we had 3 billion people in the world. Today, we have 8 billion. And by the time I'm an old man, we'll have 9.5 billion people in the world, meaning we will triple human population in our lifetime. Triple human population in our lifetime. So that's definitely a huge challenge, I think everybody would agree. And you can see here, Southeast Asia is a hotspot, Africa even more so. The Americas are relatively stable with respect to population increase, and Europe will slightly shrink. This here is one of my favorite slides. It shows the world from space in a circle over Southeast Asia that contains more people in it than the rest of the world combined. More people live inside than outside this circle. And while we have this challenge of an increasing population globally, we have people who say, let's just abandon the use of animal source foods and let's abandon the use of livestock altogether. And they say that despite the fact that we should know that we are very resource limited. What you see here in color is the only area in the world where we have cropland. Okay, this is how much cropland we have worldwide. This is how much cropland we've had over the last 50 years, and we are not going to have more cropland than that. And it is true what the FAO says, that 2/3 of all agricultural land is used for livestock. But what they don't say is the following. And now this is an important little gig here that I really like. Imagine this sheet of paper here being the entire world. This is what you see on this slide. I will now fold this sheet of paper and I will fold it twice. And now it's roughly the size of a postcard. And that sizable piece of my paper here is all the land in the world. The rest is water and ice. So the large sheet was the entire world. This is all land in the world. This here is my business card, and the equivalent amount of land of my business card is all agricultural land. So this is all land in the world. This is all agricultural land in the world, usable for human food production. I will now fold my business card, and I'll fold it twice. I fold it once into one piece that's 1/3 and the other piece that's 2/3. And then I rip my own business card into pieces. So again, the whole business card is all agricultural land in the world. The 2/3 piece is what we call marginal agricultural land. That's the land that cannot be used to grow crops because it's not fertile enough, or there's not enough water, or it's too hilly, too rocky. 2/3 of all agricultural land in the world, the marginal land, can only be used to do what? To graze. Why? Because the only thing that grows here is forage that contains cellulose, and the only animals that can digest cellulose are ruminants. Without these ruminants, we could not make use of 2/3 of all agricultural land in the world. And the same, or even more so, is true for Canada. How much of your land is used for grazing? A phenomenal amount of land. And if we were to abandon that land use via ruminants, what would happen to food production in this country? You can imagine. The 1/3 piece of my business card, the arable land, that's the cropland you see here. That is how limited we are in the world with respect to resources. And there are some clowns who say, let's stop the use of livestock. We would not be able to satisfy this drastic increase of agricultural products that stem from animal agriculture without livestock, particularly without ruminant livestock. It's very important for you. When you hear the notion that so much land in the world is used for livestock, we should instead use it for crop production directly, it's not going to happen. Why not? Because that land is not usable that way. So, really briefly, the same organization that I quoted at the onset of my talk, Livestock's Long Shadow, the FAO that wrote Livestock's Long Shadow, the Food and Agriculture Organization of the United Nations, recently wrote another report. I don't think many people have seen it. It's called the Pathways Report, and they say something very different today. First of all, they no longer say livestock produces 18% of all greenhouse gases. That number, 18%, was by that same agency reduced first to 14.5% and now 11% of all global emissions stem from livestock, they say. But what they also say is that there are ways we can reduce the impact of livestock on climate. Leading to the release of that report, and that report was released at the COP28 climate change conference that I attended in Dubai, the world media was full with articles saying the FAO, the world's most important food and agriculture organization, is putting out a new report, and that new report says that we in developed countries need to change what we eat to change or to help the world going through climate change. That's what the world media said, and they did so in articles like this. I have seen 24 articles that I could easily cite that stated we need to stop eating meat, dairy, eggs in order to help climate change. What the FAO really said was something very different. This is the report, Pathways Toward Lower Emissions. If you're interested, take a photo of this QR code, it will get you there. What the FAO really said is this. They said, this is a pretty convoluted slide, on the first column here they said, these are livestock emissions globally today. If we don't do anything to reduce them further, this second column shows how much additional greenhouse gases we will add by 2050. So by 2050, cumulatively, we will be right here in the third column. The FAO said we want to be at 2050 on the right side. So we don't want to be here in the third column. We want to be here on the right side. And what the FAO said we should do in order to get us there is using multiple tools, including productivity increases. That's the number one. Breeding, number two. Improved animal health, number three. And then they add other tools. What they also quantified was what a change of a diet from an omnivore diet to a plant-based diet would do. The FAO clearly said that's not the most important thing we can do. They said that's the second least important thing we can do, and it's right here, the fourth column. I was asked to talk about facts versus fiction, okay? And this is one of those recent reports that shows how much of what we hear day in, day out is based on fact versus fiction. The FAO never said that we need to stop eating meat or eat less or whatever, as claimed in so many of the news outlets today. So with that, just one more note. In California, where I live, we have the most ambitious climate goals in the world. 40% of methane needs to be reduced. I am very happy to report that our legislature did something really smart for once, namely not going the stick approach of using rules, regulations, fines, and or taxes like the rest of the world does to their farmers. But in California, we have deployed what's called a voluntary incentive-based approach, where the government says, we want our farmers to do their share, reduce their emissions, and in order to get them to do it, we will financially incentivize them. We tell you, you need to reduce 40% methane, and we will pay you if you do so. There will be a carbon credit if you reduce methane emissions. Our farmers jumped onto it. They have been working relentlessly on reducing their methane, and they have been very successful. By 2030, so in a few years from now, they need to reduce 40%, 40, of their 2013 methane emissions. And what shall I tell you? Of the 7.2 million metric tons they need to reduce, they are already at 4.4. Our farmers will get there by the government working with and not against agricultural producers. And that's exactly where I want to be. I'm super happy to see that it's not the cane approach, but the carrot approach that people now start to understand working so much better. And when I travel the world, and I do so a lot, I see all these other countries using the cane approach. Methane tax in New Zealand, reducing 200,000 cows in Ireland, getting rid of a third of their dairies and swine operations in the Netherlands. These desperate attempts to reduce methane have not been successful in any of these countries. They are now coming to California to learn what happens when you work with and not against those farmers. And so I encourage you to promote that same theme. Yes, we are part, but we are not the biggest part. We could be part of a solution, though. Thank you very much for your attention, everybody. I'm happy to entertain any questions if you have any. Thank you.
Well, thank you very much, Dr. Lindner. I know I could sit here all day and listen to him, and I can't express how pleased I am that you accepted our invitation to come and speak here in Manitoba and advocate for animal agriculture. So join me again in thanking Dr. Lindner. Does anybody have any questions? We can take probably one quick question. We have a mic here coming, yeah.
Thank you for that. I learned a lot. And I think it gave really good information for us to communicate with the public, so thanks a lot. One of my questions is, it feels like we live in a world now where fact doesn't matter. And I think one of the things that all of this has done is really put beef producers on the defensive. And what that does is it kind of really increases polarization between, us and our beliefs and other people and their beliefs. And I'm wondering, in some of the work you do, you said you worked with like communication teams and media. Are you looking at things that are more like behavioral change, psychology type approaches to shifting things? Because it feels like, we can put all this stuff out into the media and we can tell the story, but it doesn't necessarily do anything. It just almost increases polarization.
So I hear you. It's a question I get often. And so what we hear a lot of is not the opinion of the majority of people out there. In 98% of all refrigerators in the United States and Canada, 98%, you find animal source foods today. Meat, dairy, eggs, and so on, 98%. That very small minority out there is super vocal. And we in animal agriculture either talk to ourselves, and where has that gotten us? Or we argue with the activists. I have news for you, it doesn't work. Never wrestle with a pig. You both get dirty and the pig will like it. It's an old saying. It doesn't work. What we should do instead of arguing with some activists who will never change their ways because they want to get rid of you, period, we should instead inform an interested general public as to how we produce beef and other livestock commodities through fact-based and real information exchange. I'm not advocating for marketing, PR campaigns and so on, but fact-based information. And people are very much hungry for that. And it's not good enough that a Frank Mitterner does that in the Clear Center. It's not good enough. It's not good enough for you to say, well, we're glad that there's somebody out there who tells our story. Guess what? It's not my story. It is also my story. But it's also yours. It's also yours. I tell you one little story really quick. I know I'll be shoved off the stage here in a second. One little story. I witnessed myself, a 20-year-old student, asking a dairyman in California the following question. Is it true that there's pus in milk? The farmer looked at her and said, no comment. What a sad situation. What a missed opportunity. And these things happen all the time. That farmer should have done his job. He should have explained very clearly in the best way he knows of what somatic cell counts are, how they're being assessed, that no high somatic cell count milk goes into the bulk tank and so forth. Instead, he said no comment. And what will happen now? That 20-year-old will keep asking the question, and I guarantee you there will be some activist groups saying, of course there is, everybody knows it. These are missed opportunities, and you all have a responsibility, like I do, to counter that. We have a great story to tell. It's time that we're telling it. Thank you very much, everybody.